Afternoon, YouTube. As promised, this is kind of an update to this project that I've been working on, electric lawnmower. For those of you that have not seen my other videos, a couple of videos that I posted about this project, electric lawnmowers are not really a new thing. They've been around a long time. Ever since I've cut my own lawn, I've used one pretty much, just because of they're inexpensive. Their total cost of ownership is very low overall, in contrast to a gas-powered mower, especially when you have a lawn that's small enough to where you have to mow it, with a push mower. My biggest problem was I've had, for the last few years had one, and I think in about a 5-year period here, in the last 5 years, I've gone through 3 different electric mowers, because they were just, cheap brand that you get at Home Depot or something like that, and they just were not designed to hold up and really didn't have the power to do what I wanted to do. If you're trying to mow wet grass with them or something like that, or grass gets long, they bog down really easily. So I set out to kind of design my own and come up with a design that I thought would work really well, and I figured, if somebody else can put one of these together, surely I can too. So what I did initially was create buy a used Troy-built mower for somebody on Craigslist. It was self-propelled, had like a 5-horse gasoline equivalent engine on it. Took the engine off, built a little assembly and put it on there, and found that it was kind of headed in the right direction, but it just didn't do exactly what I wanted it to. Initially, the electric motor was mounted on the front. Electric motor actually weighs quite a bit more than an aluminum block gasoline engine does, so the weight distribution was way off, and it made turning it and maneuvering it very hard. So the first thing I did, and this actually predates this model, was move the electric motor to the back. That makes it to where it puts a lot of the weight on the rear wheels and makes it a lot easier to maneuver, and it does. The second thing I did was, the Troy-built was a front-wheel drive, and it was single speed, and it also had, I had kind of stolen basically a switch off an old electric lawnmower that I'd thrown away and bolted it to the right-hand side over here, and it fit, but it didn't exactly fit the way I wanted it to. So it was workable, but I thought there's got to be room for improvement here. So I just happened to be browsing on, like it was Craigslist, or maybe it was that one app that you get stuff on, WhatsApp or whatever you call it, that you can, buy and sell stuff on, and I saw this John Deere mower, $40, variable speed transmission, rear wheel drive, had like a 5-horse or 6-horse equivalent gas engine on it. And I thought, ooh, that's a pretty good deal. I mean, the gas engine wasn't running correctly. It would start, but had some other problems. It didn't matter to me because I didn't care about that anyways. $40, I snapped that dude up and brought it home, and immediately set to work about mounting my all my stuff to the deck with a few modifications. Again, bear with me if you've watched the other videos. For those of you that haven't, basically it's basically just a 2-horse 120 240 volt induction motor. It's got a belt drive going to the spindle that drives the blades, and actually it has a belt underneath that drives the belt for the transmission. I had the base fabricated out of 4-inch steel, did all the measurements and took it to the local steel shop, and I think it cost about $90. A little expensive, probably besides the motor, the most expensive part of this project. But I mean, it would be really difficult to do that myself. I don't have the equipment, so it was just a lot easier to have them do it. They did it perfect, lined out. I built the bearing assembly myself using just a couple of flange bearings, some bolts, a couple of little, there's a term for these, but they're just spacers. I actually ordered these online and wound up cutting each of them in half to get the right size spacer that I need. And it's basically just 2 flange bearings stacked on top of one another, with a 7/8 inch shaft that I had milled, and it's actually tapped on the other end where it has the original bolt that went into the first mower that I built. I had it tapped at the same size holes that would be needed to fill the bolt, fit the bolt. And that wasn't bad either. That was actually pretty inexpensive to do that. I think I paid $30 for the shaft and wound up cutting half of it off, because it was probably 12 or 24 inches by the time I got what they had or were able to get. like I said initially, the um, motor control was up on the right hand side. It came off an old mower that I'd thrown away, and it was just kind of cheap plastic, same as the rest of the mower. And I decided that when I did this, I really didn't want to go that route. Figured there had to be a better way of doing this. The dead man switch was still intact, and I did some investigating, see what I could come up with, and I kind of created my own control box. And all this really does is it's got a 12-volt transformer in there that feeds a switch, which this dead man switch is attached to. It's a pull switch basically. It's just bolted into the back of the box inside here, and the cable I wrapped around and put kind of a hook on it, and was able to attach it to the pull switch. And whenever you pull it, the dead man switch, it just pulls this little pull switch up and creates closes the circuit for the 12 volt, which is attached to a 120 volt contactor that sends the power from the incoming feed lines to the motor. And so it ties in with the dead man switch really well. It's been reliable, not had any problems with it, and it kind of does exactly what I want it to do. I kind of had to rig the dead man switch a little bit to get everything to fit right, but I mean ultimately it works pretty good. Only thing I would probably do differently is just kind of add another spring up here to where it actually pulls the dead man switch all the way back up, because sometimes it'll stick. There's not enough tension on that switch. You know, if you let it go and don't force it a little bit, it'll actually stay running, which is not, you know, it's a safety issue primarily. So it's got a lot of power. I mean, this thing runs probably equivalent to a gas engine in terms of power, which was what I was looking for. You know, it doesn't bog down when the grass is wet. It doesn't stall out or anything like that. You just want to make sure it's hooked up to 100. You know, if you're using 120 volt, hooked up to a 20 amp circuit breaker, or else you'll blow a circuit breaker or fuse. It seems to work just fine. It runs cool by the manufacturer's standards. I mean, it gets warm obviously when you're using it, but it doesn't exceed the temperature. I've measured it with one of those laser thermometers, and it seems to be within the parameters that they specify. The outside of the case does get hot, but for electric motors like that, that's supposed to happen to radiate heat out from the windings. So like I said, there's definitely some modifications I'd like to make if I had the time and wanted to spend the money to do it. This is kind of a working prototype, and I'd call it almost pretty well a finished prototype, because it does basically exactly what I want it to do. So it works good. I'll kind of give you a demonstration here of it in action. And like I said, this is kind of neat. It took a little bit to put this together, but I was pretty pleased about what we ended up with. So we got it plugged in, you know, or just laying out here because I just hooked it up. To start it, you just pull the dead man switch and then move the drive lever forward, and it starts going like so. Got to go to the hardware store and get a spring to fix that, because we don't want that sticking. Usually it's not a big problem, but it's like I said, to me it's a safety issue. So it works pretty good. I'm very impressed with it. I think it turned out really well. To me, this is kind of a finished prototype, although there are things I probably would change about it. None of them affect the operation. It's mostly just cosmetic stuff. Yeah, it works really good. Maintenance, you don't have to do anything to it except sharpen the blades and, you know, grease the bearing pile once a year, and that's about it. It didn't really require any maintenance outside of that. Yeah, so anyway, yeah, it works great. You know, I know when I was looking to do this, I kind of looked online to see if I could find anybody who had done anything like this, and there weren't any really. There were a handful of really good examples, but just one or two. So I kind of wanted to show everybody, you know, what I did to kind of make this work. It's a great setup. It doesn't technically meet the federal blade stock requirements. There are laws that say, you know, that manufacturers have to put on, you know, obviously the dead man switch is one where it's got a brake. You can do that, and you know, I actually could install a I can't remember what they call it, but it's like a quick stop mechanism for an induction motor, and it feeds a DC current back once you release the power on it to the induction motor, which will stop it very quickly. Those are industrial grade electrical stuff, and I have not been able to find one that's actually reasonably priced, so that's why I've never done it. And there again, to me, it's me using it. You know, I don't have to worry about anybody else getting hurt because they're not using it. They're not allowed to use it. But overall, it's been a successful project. I'm very pleased with it, and if I do any significant modifications that, you know, make it any better, I'll be sure to show you guys. Anyway, thanks for watching.